All right, so the hypotenuse leg theorem says that if you have a right triangle, or if you have two right triangles and their hypotenuses are the same, right, remember that's the longest side, the side that's across from the right angle. Obviously the right angle is making an arrow towards the hypotenuse. Okay, so if the hypotenuses are the same and they have a leg that's also congruent, then that means that those two triangles must be congruent. And remember, like I said in the proof, this is actually side-side angle, right? Side-side angle. And usually that doesn't work, but in the situation of a right triangle, it works, okay? So that's the only thing that can make SSA right, is if it's a right triangle. Remember, because normally geometry is pure, and SSA, since it's a naughty word backwards, doesn't work. But in the case of a right triangle, it's okay because we can call it HL theorem instead of SSA. Okay, so remember that doesn't generally work just with a right triangle. Okay, so how can we use it? So if we have situations like these, and we have right triangles, then that's another tool in our toolbox, right, in order to prove congruence. And so here it says, for what values of x and y are the triangles congruent by HL? Okay, so by HL it'd have to be hypotenuse leg, right? So if these are right angles here, the hypotenuses would have to be congruent. So 4x plus 1 must equal 13, right? And also they'd have to have legs that are congruent, right? So so we'll say these two legs are congruent since those have assigned variable values. So we'll say, well, 2x plus y must equal 8x minus 2y. So then we can solve. So we can solve for x here, because in this equation we only have one variable. So we can subtract x from both sides. We get 4x equals 12. Divide by 4. And we get x equals 3. So then we can take that 3 and plug it in here and here. And so we can get 6 plus y equals 8 times 3 is 24 plus minus 2y, excuse me. And we can add 2y to both sides. And while we're at it, let's subtract 6 from both sides. So we get 3y equals 18. And then we can divide by 3. And we get y equals 6. All right. And in a similar fashion, we can do this one, right? So we can say, okay, well, 2x plus 1, the hypotenuse here must equal the hypotenuse here, right? So that must equal x plus 3. And then we can say, okay, well, these legs would have to be congruent as well. So we can say that x plus y must equal 3x minus 3y. All right, so I'm going to solve for this equation first because it only has one variable, once again. So I'm going to take away x from both sides and subtract 1 from both sides. So I'll get x equals 2. I can take that x value 2 and plug it in here and here. So I'll get 2 plus y equals 6 minus 3y. And I'll add 3y, subtract 2, and so we'll get 4y equals 4. And we can divide by 4, and we'll get y equals 1. All right, so those are the values of x and y that make the triangles congruent by HL.